Basically, what I wanted to try to do is what we do every day at Undercurrent, which is try to make a little bit of sense about all the various topics that we've heard so far today. And I've been lucky to be in the audience for a lot of them, so I've been noticing these patterns. But essentially, where we start is observing and seeing what's happening, and then can we unpack why that is and where we might be headed. And so the first place that I want to begin is just this reality that we all live in now, and none of this is news to anybody in the room, but this idea that it is much, much, much easier today than 5, 10, 15, 20 years ago to do two things. One, bring an idea to life, and two, to bring that idea or that product when it's manifest to scale. And so today we saw even in the economies of scale between somebody inventing a Tesla and the next generation of, a lit motors, or if you look at what's happened in, in the tool space, if you look at the time to reaching scale among some of our most popular tools, whether it be an Instagram or a Facebook or an Uber or whatever it might be, it just keeps getting compressed and compressed and compressed. And so now a kid in a garage can, not be able to afford a 3D printer, spend some time with their friends, use the internet, and a year later be the founder of MakerBot. Like, we just live in that world where you can bring an idea to life, you can use Kickstarter, you can fund it, you can collaborate, you can use all the tools that are available to us. And because you can do that, it sort of changes the world around us in some really interesting and profound ways. So assuming that you buy this, that it's easier to bring it to life and that it's easier to bring it to scale, one of the questions is why? So what's sort of the underpinning of these two ideas? And there's actually just a pretty simple model for that. One is this idea of platforms. So almost every company that we think of now that's building is building on the shoulders of the people that came before them. When you launch a tool now and you have your whole back-end cloud architecture and infrastructure, you might be leveraging Amazon Web Services. So you now are 10 days out of past funding, and you're using this robust, rich, scalable, amazing open architecture, or any of their competitors, that are all available to you because someone else did the work of building that, and now you can leverage it. And the platforms are multivariate and all over the place, whether it be using YouTube as a content channel, using a technology, using infrastructure around mobile, using even a API or a build tool or a prototyping tool. They're all available because some other business created something and then either open sourced it to the world, or made that their product, or let that exhaust be something that you could start to tap into. So the idea of the platform is a pretty important enabler. And the second is this idea of networks, which I know Noah's a big fan of talking about and thinking about, pontificating on. And the big thing with networks is that once the groundwork is done, once the track is laid, you can then run things over it with a lot more speed. Things can reach folks with a speed that was unprecedented before. So if I have a great video, if I have a great piece of content, if I have a great idea, if I have a Kickstarter campaign to create potato salad, see, there's some people that read the news, then that can reach millions and millions of people through the network. Or if I have an app idea that's really bright, that app idea can transmit across the network and be downloaded 1 million times or 100 million times. And so the fact that networks are being built all the time and that different businesses are in the process of simultaneously leveraging and building upon platforms and networks, as well as creating the next for the people that will come after them, is creating this climate of rapid innovation. So an example, you take Uber, for instance. They didn't have to invent the mobile phone. They didn't have to invent GPS. They didn't have to invent the iOS App Store. They didn't have to invent the luxury sedan. They didn't have to invent the livery. They didn't have to invent 99% of the stack of value that they're actually providing to the end user. They just got to do that thin layer of icing, which was how do you knit together this collection of vehicles and users into a network and make it work, make it sing. And the same thing's true for a lot of the other big network models, like an Airbnb. So they're able to do that. At the same time, because they're building that network, someone else could come in and start to think about, how do I market to that network? How do I leverage that network? How do I offer, they just partnered with some vehicle manufacturers who said, hey, we're going to offer cars at a discount with a better financing option to that audience. So that goes on. And then Tesla, a little bit more of an uphill battle because there's not as much to leverage, but they're certainly leveraging battery technology. They're certainly leveraging and building upon it. They're leveraging OSs. So they have a Linux-based Ubuntu OS behind that 17-inch screen in the dash. So they're not rewriting OS from scratch. So they're leveraging platforms. And at the same time, they're building networks. The whole idea of a long-distance supercharger network was not real and is now starting to become real. And by opening their IP and allowing any manufacturer to build a charging compatibility with that network, now technically anybody with an electric car could borrow that and treat it as a platform. So that's just a little bit of background. Now there's a couple things that have happened in the world as a result of this. The first is that it's much, much harder to stay at the top of the heap. Things are changing so quickly, and there's so much pressure from that lift of people leveraging other people's IP and ideas and understanding that now basically what you have is, in 1960 or so, the average lifespan of an S&P 500 company was about 60 years. So if you're on the list, you probably have a 60-year run. And you start to sort of fast forward and you see some different dips, but you end up in a world where by 2025, 2030, that number is more like 12 to 15 years. So a dramatic cut in your ability to stay at the top because of all this pressure, all this change that's going on. So that's one thing you have to grapple with. And if you're a small company and you have the right kind of systems, maybe you can grapple with that. But if you're a big company with hundreds of thousands of employees and you're trying to do 40 products in 40 countries, the need to change at this rate and to sort of fight against these forces is really, really difficult. And the reason that is because we also simultaneously live in a world that is incredibly complex. So big systems, systems that are sort of the main institutions that drive the world, are complex. This is your healthcare.gov system. It's a total surprise that it didn't work. I mean, you know, this is not like an architecture drawing. This is not some back-end system where every single thing that's exchanging data is drawn out here. These are literally the groups of people, the branches of government, the functional offices, the pieces of the puzzle that all have to communicate, collaborate, agree, move data through the system in order to deliver that healthcare.gov strategy. So if you're staring at a system like this, and most big important institutions are, and you're also staring at that other chart of how things have to change more quickly, the question on your mind is, how do big things react in a world that's changing really fast? How do they change in a way that makes sense at scale? And so that's a puzzle that we've been sort of obsessing on for the last couple of years. And what I wanted to do was share with you guys what we found. We basically found that there are some systems out there that are simultaneously big and complex, but also quite adaptive and quite resilient and quite responsive. And so here they are. So basically, here's just 3 examples. There are dozens and dozens and dozens. And the Google search that you want to do if you really want to get into this is just start to look into complexity science, complex adaptive systems. There are hundreds of them out there, and I've picked 3 to highlight today. So first, ants. A hill of ants has hundreds and hundreds and hundreds, or thousands and thousands and thousands of individual participants, individual agents that are working on behalf of that colony. And unlike a traditional system, the queen is not issuing orders. So there is no kind of, today you get up and you go out and you start to, you know, pick up food and forage, or we need you to go clean up the mess that the rainstorm made last night. The ants all just wake up, and somehow, through some miracle of communication and complexity, they decide what to do, and they do their work, and they create structure. And what's amazing about it is they do things that are almost impossible to understand without imagining that there's some kind of communication. So if you actually study anthills, there might be the trash dump over here, the food supply over here, and the entrance to the colony over here, and they're equidistant, as if an architect designed them. But there's no communication that talks about distances. There's no interaction like that. There's no architect ant that makes the decisions and tells everybody where to go. They just run around and they figure it out. And it turns out there's a set of simple rules about the way they work that allows that to happen. So then we look at the immune system. So everybody in here has an immune system that every day creates about 10 million new lymphocytes by randomly recombining the genes in your immune system. And so those lymphocytes go out, and their job is to go find pathogens that might be bad for you, things that are in your body or in the environment that are enemies. And so the 10 million go out, and eventually 1 or 2 of them comes upon a pathogen that it's a fit for. Their particular unique expression fits that pathogen. Maybe it's a flu, maybe it's some other kind of virus or bacteria. And when it finds it, it connects and it binds. And when it binds at a high enough quantity, it releases a signal that, holy shit, we've got a winner here. And I like to call that product market fit. And so what happens is the lymphocyte has product market fit. It rushes back to the lymph nodes, which I like to think of as the VCs. And it's like, I have a winner here, and what it does is it gets funding and ends up replicating itself over and over and over again. It scales, right? So that's a system that basically has to deal with infinite complexity when it comes to the number of competitors that are going to try to F it up. Any number of things could come into your system that are not you, and it needs to be able to plan for that. So the way it does it is by creating this enormous variety of potentials and then doing a really good job of replicating and expressing the ones that find a fit. And then the last, and the one that's near and dear to a lot of our hearts, is just the internet. The internet, although people are trying their damnedest right now to do this, does not have a central regulatory body. It has some basic rules, it has some underpinning and some structure, but you can take a website down and the other websites stay up. You can do a DOS attack and people put it back together again. It is a living, breathing system that continually adapts and evolves and grows and changes and creates really powerful outcomes. So all three of these systems do a really good job of being very big, very important. They need to work. It's all, you know, pretty serious life or death stuff. And yet they do a really good job of adapting to circumstances as they change. And so what I want to do very quickly is just highlight, if we compare the old model, the model that we're sort of taught in business school, that you see in most 20th century organizations, that you see in 20th century government, to what these systems are suggesting we should be like, you really see a contrast. And that contrast starts to really speak to why the companies that we get excited about today, when you say, who's a company you're scared to compete with, those companies that come off the tongue tend to be organized and structured and going to market and doing their work in a way that feels a lot more like the ants and the lymphocytes and the internet, and a lot less like the institutions of our parents or our grandparents or their grandparents. And so I'll just run you very quickly through those contrasts. So the first is that 20th century systems embrace planning, right? We know what's going to happen. The world doesn't change very fast, so I can make a 50-year plan. I can do a 5-year plan for the business. I can tell you what's going to happen, and we can make a decision about that. So I'll build a handbook. The new model says, no, we have to embrace uncertainty. We don't know what we don't know. Things will change. So if we build a long plan and we go try to execute it, it's going to become useless. And it really boils down to, if you're taking a boat out on the ocean, do you want to steer once and then wait a year and pray? Or do you want to steer every minute? You know, you want to have continuous steering. So embracing uncertainty means accepting that planning has a lot less value in a world where things change rapidly than it did in a world that stayed the same. And we need a new form of de-risking what we're doing that isn't just the 15-page plan, that isn't a requirements document for a build that is going to go into a waterfall process.